Sum-Product Identities. Objectives. Express products as sums. Express sums as products. Expressing products as sums for cosine. We can derive the product to sum formula from the sum and difference identities for cosine. If we add the two equations, we get the cosine of alpha minus beta plus the cosine of alpha plus beta is equal to 2 cosine alpha cosine beta, and our sine alpha sine beta will cancel out. Now we need to just divide both sides by 2, and I have my new identity. The cosine of alpha times the cosine of beta can be expressed as the cosine of alpha minus beta plus the cosine of alpha plus beta divided by 2, or let's take the whole thing times 1/2. Write the product as a sum or a difference. Now inside this problem, I can see I have the product of these cosine of angles. So I can use the formula that we just derived. I'll just have a 2 multiplying out front. So I'm going to have 2 times 1/2 times the cosine of the difference of those angles plus cosine of the sum of those angles. Now when I simplify, my 2 times the 1/2 in front will get removed. So I'll have the cosine of 7x minus 3x is 4x divided by 2 is 2x plus the cosine of 7x over 2 plus 3x over 2, that's going to be 10x over 2, which is the cosine of 5x. Let's write this product as a sum, a cosine of 2 theta times cosine of 4 theta. This will be 1/2 times the cosine of 2 theta minus 4 theta plus the cosine of 2 theta plus 4 theta. Now we simplify. This is 1/2 times the cosine of negative 2 theta plus the cosine of 6 theta. Now we'll have 1/2 times, I know that the cosine of negative 2 theta is the same as the cosine of positive 2 theta from the even-odd identities, and plus the cosine 6 theta, and we're finished. Now expressing the product of sine and cosine as a sum. So we can derive the product to sum formula for sine and cosine from the sum and difference formulas for sine. If we add the sum and difference identities, this is what we'll get. The sine of alpha plus beta plus the sine of alpha minus beta is equal to 2 times the sine of alpha times the cosine of beta. Now to finish solving for sine alpha cosine beta, I'll multiply both sides by 1/2. So the sine of alpha times cosine of beta is going to be equal to 1/2 times the sine of alpha plus beta plus the sine of alpha minus beta. Write the product as a sum. Sine of 4 theta times the cosine of 2 theta. This is going to be 1/2 times the sine of 4 theta plus 2 theta plus the sine of 4 theta minus 2 theta. Simplifying, I'll get 1/2 times the sine of 6 theta plus the sine of 2 theta. Here, the sine of x plus y times the cosine of x minus y. Using our formula, we'll have 1/2 times sine of x plus y plus x minus y. Then we'll add the sine of x plus y minus all of x minus y. So that makes a minus x minus a negative y. Now I simplify. 1/2 times sine of 2x plus sine of 2y. Expressing products of sines in terms of cosine. Expressing the product of sines in terms of cosine is also derived from the sum and difference identities for cosine. In this case, we will first subtract the two cosine formulas. This gives me a cosine of alpha minus beta minus the cosine of alpha plus beta, and that is going to equal, here I have the cosine of alpha, cosine beta, minus the cosine alpha, cosine beta, so that goes away. And then I have the sine of alpha, sine of beta, and I'm subtracting a negative sine alpha, sine beta, so I'm actually adding a sine alpha, sine beta, which gives me 2 sine alpha, sine beta. Now multiplying both sides by 1/2, I'll have sine of alpha, sine of beta is equal to 1/2 times the cosine of alpha minus beta minus the cosine of alpha plus beta. Write cosine 3 theta times cosine 5 theta as a sum or a difference. I'm going to use this formula, 1/2 times the cosine of the difference of those angles plus cosine of the sum of those angles. So simplifying, I have 1/2 times the cosine of negative 2 theta plus the cosine of 8 theta. And I know, with cosine being an even function, this will simplify to 1/2 times the cosine of 2 theta plus the cosine of 8 theta. Use the product to sum formula to evaluate cosine of 11 pi over 12 times the cosine of pi over 12. The formula I will use is 1/2 cosine of the difference of those angles, 11 pi over 12 minus pi over 12, plus cosine of the sum of those angles, 11 pi over 12 plus pi over 12. Now, to simplify from here, I have 1/2 times the cosine of, this is 10 pi over 12, or 5 pi over 6, plus the cosine of this 11 pi over 12 plus pi over 12 is 12 pi over 12, or pi. Now I can use my special angles, and the cosine of 5 pi over 6 is going to be the negative square root of 3 over 2, plus the cosine of pi is negative 1, so I'm going to make this a negative here. This gives me a negative square root of 3 over 4 minus 1/2, which is negative square root 3 minus 2 all over 4. And here are all of your sum to product formulas. Write the sum as a product. Sine 4 theta minus sine 2 theta. Our formula says that 2 sine of 4 theta minus 2 theta over 2 times the cosine of 4 theta plus 2 theta over 2 is the way to write that as a product. Now we simplify. 2 sine of 2 theta divided by 2 is theta, times the cosine of 4 theta plus 2 theta is 6 theta, and 6 theta divided by 2 is 3 theta. Let's write this sum as a product, the sine of 3 theta plus the sine of theta. This will be 2 sine of 3 theta plus theta over 2 times the cosine of 3 theta minus theta over 2. And simplifying, I get 2 sine of 2 theta times the cosine of theta. Find the exact value of cosine 15 degrees minus the cosine of 75 degrees. Verify your answer with a calculator. Here I have negative 2 times the sine of 15 degrees plus 75 degrees all over 2 times the sine of 15 degrees minus 75 degrees all over 2. This gives me a negative 2 sine of 75 degrees plus 15 degrees is 90 degrees divided by 2 is 45 degrees times the sine of 15 degrees minus 75 degrees is a negative 60 degrees divided by 2 is negative 30 degrees. So this is negative 2 times the sine of 45 degrees is square root of 2 over 2 times the sine of negative 30 degrees is a negative 1/2. Multiplying all of this together, I'll have a positive square root of 2 over 2. So in checking this with the calculator, first make sure that your calculator is in degree mode. We'll put in the trig menu the cosine of 15 degrees minus the cosine of 75 degrees. And enter, I get the square root of 2 over 2, just to show you the square root of 2 divided by 2. Those decimals match. Prove the identity. Cosine of 4t minus cosine 2t, all divided by the sine of 4t plus the sine of 2t, equals a negative tangent t. Certainly the left side is more complicated, so we'll go ahead and try and simplify that side. I can use my sum to product property. For my numerator, I can use this identity. The difference of the cosine of angles is equal to negative 2 times the sine of the sum of the angles divided by 2 times the sine of the difference of the angles divided by 2. So this is going to give me a negative 2 sine of 4t plus 2t is 6t divided by 2 is 3t times the sine of 4t minus 2t is 2t divided by 2 is t, all divided by, for the denominator of this, we'll use the sum of the sine of angles. So that would give me a positive 2 sine of 4t plus 2t is 6t divided by 2 is 3t times the cosine of 4t minus 2t is 2t divided by 2 is t. And now we simplify from there. Our 2's get removed, our sine of 3t get removed, and I'll have the negative sine of t over the cosine of t, which is negative tangent t. Cosine squared theta minus 2 is equal to cosine 2 theta over sine squared theta. To verify this identity, let's work on the left side, the more complicated side. This is 1 over sine squared theta minus 2. Now I see I have just a single fraction over here. Let's see if I can get these two terms together. That means we'll need a common denominator. I'm going to multiply this by sine squared theta over sine squared theta. That gives me a 1 minus 2 sine squared theta over sine squared theta. Now I know that 1 minus 2 sine squared theta is cosine of 2 theta, and that is over the sine squared theta. Tangent theta times the cotangent of theta minus cosine squared theta is equal to sine squared theta. Well, I know tangent of theta times cotangent of theta is equal to 1. That's minus cosine squared theta. And I know that 1 minus cosine squared theta is sine squared theta.